Good evening, dear students. Today we are going to discuss the second session of three-dimensional geometry. Now, before I start, could you please confirm that you are able to hear my voice very clearly and able to view the screen properly, dear students?
Yes, sir.
Okay, great. So, today, as I was saying, that we will discuss, two topics. The first one is that equation of a line in space, and then we will discuss about the angle between two lines. Now, first one is that if you recall in class 11, we discussed the equation of line in two dimensions. Now here we will be discussing the equation of line in both vector equation and Cartesian equation of a line in space. Okay, I repeat once more. So here what we will discuss? Here we will discuss the vector equation and Cartesian equation of a line in space. Now a line is determined uniquely if it passes through a given point and has a given direction, or it passes through two given points. So let's discuss the first one briefly. Suppose in the first case, what we get here, dear students, is that we can determine the straight line uniquely if it passes through a fixed point. Suppose this is a fixed point A and having a given direction. What does it mean? That means the straight line can be of this direction, then it is a given direction, right? So we can consider that it's passing to the point A. This is one direction, or the straight line can be of this direction, correct? In this way, if we know it is a specific direction, a given direction, and it is passing through a particular fixed point, then we can determine the straight line uniquely, and eventually we will able to find the equation of that line. And the second one is that if a line passes through two given points, that means what? There is a point and this point, and passing through these 2 points we can construct a straight line uniquely. Uniquely means what? As you know, that only one straight line we can construct passing through two given points. So if you see here, there are 2 points A and B, and passing through these 2 points we can construct, this is the straight line as you see in the screen. Now let us discuss all these things in details about the formation of the equation. And first what we are going to discuss is that, let me first place this one in the screen, and after that I will discuss. The first point what we are going to discuss, dear students, is that the equation of a line through a given point and parallel to a given vector B. Okay, if you recall, just a minute back I said that we can determine a straight line uniquely if it is passing through a fixed point and having a given direction. So now that given direction is actually implied by means of this statement that it is parallel to a given vector B. So what we are going to do, dear students, here, that we are going to find the equation of a line through a given point. Suppose this is the point, this is the point, a fixed point, and parallel to a given vector B, and this is the vector B, as you see here. This is the vector B. Okay, got it? And we are going to find the equation of that line. So let A, and what is that line here? Line here is that line L. As you see, this is the line. So let A be the position vector of the given point A with respect to the origin. So one fixed point, given point. So given point, we are considering that given point as A, point A, and it is having a position vector A, okay, with respect to the origin O. That means in simple terms we can say that the vector OA is nothing but the is represented by A, correct. Now let L be the line which passes to the point A and is parallel to the given vector B. So two things we are aware of. One thing is that it is passing through a fixed point, so we know the position vector, and it is parallel to a given vector B. These two information is known to us, vector A and vector B. Now with these two information, we are going to form the equation of that straight line L. And how we are going to form the equation of that straight line? Let's see. Now let us take a point P, an arbitrary point. That means this point P can be anywhere in that straight line, and let us have the position vector of this point P be R. That means what? With respect to the origin. That means we get OP is the vector R, correct. I hope it is clear. Now we see that the vector AP is parallel to the vector B, obviously, because the given line L is parallel to the vector B, correct. So that means that AP is parallel to the vector B. Now we know if two vectors are parallel, then we can say the one vector is a scalar multiple of the other vector. Now as we see that the vector AP is parallel to the vector B, what we can say? We can say the vector AP is lambda into vector B, where lambda is some real number, correct. I hope it is clear. Now let us look into the triangle AOP. Now if we look into this triangle AOP, we will see the vector AP is nothing but it is AO plus OP, okay. So if you look into this triangle, what I am saying, if you look into this triangle OAP, we can say that vector AP is equal to, vector AO plus vector OP. Now that vector AO, that means minus vector OA, correct, minus vector OA plus vector OP. So that means we see that vector AP is equal to vector OP minus vector OA, which is actually written here. I just explained little elaborately. Now we have just learned the vector AP is nothing but lambda into B. So then we can say that lambda into B is equal to the vector OP, which is R, minus vector OA, that is A. So lambda into B is equal to R vector minus A vector. So if we write it in more clearly, what we can write is that the R vector is equal to A vector plus lambda into B vector. That is the equation of that vector equation of that straight line. So dear students, if we have two information, the first information, the straight line is passing through a fixed point. That means we know the position vector of that point, and that position vector we defined as A, as we explained here, and that straight line is parallel to a vector B. Then we can find the equation of that straight line as R equal to A plus lambda into B, where R is any point on that straight line and its position vector. Means what I wanted to say, where R is the position vector of any arbitrary point on that straight line. In this case it is P. Okay, P is that arbitrary point whose position vector is R. And what is lambda? Lambda is any real number. Now dear students, as A and B are fixed, so what we get, I want to explain little bit more here. R vector is equal to A plus lambda into P vector. Now A and B are fixed because A is a fixed point, so its position vector is a fixed one, and B vector is a fixed vector because our straight line is parallel to this vector B. So what is only varying is lambda because it is a real number. So you vary lambda and you get different values of R. Okay, because A plus lambda B, in which A and B are fixed, the only thing you can vary is that lambda, where lambda belongs to the set of real numbers. You vary lambda, you get different values of R, and all those R are nothing but the points on that straight line, and it is the position vector of those points. So as you vary lambda, you get different position vectors on that straight line. Okay, so this is the way we can find the vector equation of that straight line. Now we will discuss within few minutes about the what will be the Cartesian equation of that straight line, that will come. But before that, a very important remark I want to give, and please note it down. In fact, you should note it down whatever I am discussing. Now the vector B, if we represent that vector B in the component form as vector B is equal to AI cap plus B j cap plus C k cap, where A, B, C are real numbers, and one thing very important is that this B, what is the component of that is the coefficient of j cap and vector B should not be mixed up. These two are completely different thing. I repeat once more, the B, which is the coefficient of j cap, and the vector B are two different things. Okay, so now let's come back. So B vector, if we represent the B vector as A I cap plus B j cap plus C k cap, where A, B, C are the direction. In fact, let me rephrase the statement correctly in a more clear manner. If we can represent the vector B in the component form as A I cap plus B j cap plus C k cap, then we can conclude that A, B, C are the direction ratios of the line representing that vector. And conversely, if we see that ABC are the direction ratios of a line, then the corresponding vector representation of that line means directed line, so the corresponding vector representation of this line is A I cap plus B j cap plus C k cap, correct? Okay, and more importantly, what I can say is that either we can consider that line as A I cap plus B j cap plus C k cap, or it will be a parallel to the line. Okay, so because we know direction ratios could be anything, right, in parallel to the given direction ratio. Means what I wanted to mean is that if A, B, C are the direction ratios of a line, then we can say KA comma KB comma KC also direction ratios of the parallel to that line. So that's why it is mentioned. The remark, let me read out once more. If vector B is represented as AI cap plus B j cap plus C k cap, then ABC are direction ratios of the line, and conversely, if ABC are direction ratios of a line, then the vector B, which is AI cap plus B j cap plus C k cap, will be parallel to the line, correct? And as I always explained in the beginning, that we should not get confused with the vector B and the component with that coefficient of j cap, that is B. I hope it is clear, dear students. Now let's proceed with the Cartesian equation of that particular line. Okay, and how we are going to do it, let me show you. In fact, we are going to derive the Cartesian equation from the vector equation. So dear students, with respect to the Cartesian coordinate system, that point A, if you remember the fixed point A, that is represented by the coordinate x1 comma y1 comma z1. Okay. So what I wanted to mean is that if I go little bit above, so this point, what you see it here, this point in the Cartesian coordinate system, let's represent its coordinate is x1 comma y1 comma z1. Then what happens, dear students? So we can represent that vector A as x1 I cap plus y1 j cap plus z1 k cap, that we already aware from our vector algebra class. Okay, that is the vector A. And the direction ratio of the line, that the line parallel, what we discussed, that the straight line should be given to a parallel to a given line. If that parallel line is having direction ratios as ABC, then obviously the vector B can be represented as A I cap plus B j cap plus C k cap. We discussed this, right? Where we discussed the remark section. Okay, remark section. If you read it here, this one. Okay, so I am not again saying this thing, but from that information we are writing that the vector B is equal to A I cap plus B j cap plus C k cap. Correct? And A vector we already discussed that it is x1 I cap plus y1 j cap plus z1 k cap. Now what is R? R is any arbitrary point on that straight line whose equation we are going to form. Now any arbitrary point is having the coordinate x comma y comma z, that point arbitrary point P. Okay, then obviously its direction its vector representation in the component form will be r vector equal to x I cap plus y j cap plus z k cap. Correct? Then dear students, what we can write is that if these three values of A, B and R, if we write into the vector equation that R vector is equal to A plus lambda into B, we will get what we will get. So let me write it down so that it will be more meaningful to you. So that implies we can write x I cap plus y j cap plus z k cap is equal to the vector A plus lambda vector B. What is the I cap coefficient of I cap for the vector A? It is x1. And what is that for the vector B? That is A, that is coefficient of I cap for the vector B is A, this one, but it is multiplied with lambda. So what you can write is that x1 plus lambda into A I cap plus y1 plus lambda into B into j cap plus z1 plus lambda into C into k cap. So then, as these two vectors are equal, which are represented in the component form, we can say that this x, which is the coefficient of I cap in the left hand side, is equal to x1 plus lambda into A, which is the coefficient of I cap in the right hand side. So that's why we have written x1 equal to x1 plus lambda A. In similarly, we can write y equal to y1 plus lambda B and z equal to z1 plus lambda C. So now from this we can eliminate lambda. And how we are going to eliminate lambda? Let me show you. Okay. So what we do is that lambda equal to, from this equation we can get lambda equal to x minus x1 by a. So that's what we have written here. That same lambda from this one, from this equation, is y minus y1 by b. That's why we have written here. And the same lambda from this equation is z minus z1 by c, and that's why we have written here. So we get the Cartesian equation of the line as x minus x1 by a equal to y minus y1 by b is equal to z minus z1 by c, and this is also known as the parametric equation, where lambda is the parameter. So dear students, the vector equation is r vector is equal to a plus lambda into b. Okay, that is the vector equation. Okay, so this is vector equation. Vector equation, and corresponding Cartesian equation is this one. Now what is the correlation between these two? That the vector A is nothing but x1 I cap plus y1 j cap plus z1 k cap. These are the, this is one, x1 I cap plus y1 j cap plus z1 k cap, that is for the vector A. And what is vector B? That is equal to a I cap plus b j cap plus c k cap. And what is vector R? Is an R is an position vector of any arbitrary point on that straight line. That is nothing but x I cap plus y j cap plus z k cap. Now what is ABC? ABC are the direction ratios of the line or parallel to that line. Okay. Now instead of direction ratio, if we have the direction cosine of the line as LMN, which is the convention to represent direction cosine, then we can write the equation of that straight line as x minus x1 by L is equal to y minus y1 by M is equal to z minus z1 by N. So dear students, let me conclude that if a straight line is passing through a fixed point and is parallel to a given line, then the vector equation is r equal to a plus lambda b, where a is the fixed point and its position vector is a, and the fixed line and parallel to a line, parallel to a vector b, means given direction means it is parallel to a given vector, and if that vector is b, then we can say the equation of that line is r equal to a plus lambda b. Now if the same straight line, that is, this is whatever is represented in the vector form, but if the same straight line is passing through the fixed point x1 comma y1 comma z1 and having the direction ratios as a comma b comma c, its Cartesian equation is x minus x1 by a equal to y minus y1 by b is equal to z minus z1 by c. This is one thing. Now instead of the direction ratio, if direction cosine of that straight line are given, that is L, M and N, then we can write the Cartesian equation of that straight line as x minus x1 by L is equal to y minus y1 by M is equal to z minus z1 by N. Yes, you are saying something? Okay. All right. Is it clear so far? Any doubt here, dear students? So far, is it clear? Hello? Is my voice clear to you, dear students? Hello? Okay. Now let's continue. So the next one, what we are going to discuss is that, we'll solve couple of questions. Okay. So the first question, what we are going to solve it here. Hello dear students, are you able to hear me very clearly? Just a minute, maybe there is a network issue. Okay, so let me continue. So here the question is that find the vector and Cartesian equations of the line through the point 5, 2, minus 4.
Sorry, didn't share screen, sir.
Okay, just a minute. Let me share the screen. Actually, internet goes off for some time, I hope. Yeah. So please confirm that you are able to view the screen. Could you please confirm that you are able to view the screen, dear students? Hello.
Yes, sir.
Okay, great. So what I wanted to say is that we need to find the vector and Cartesian equation of the line through the point 5, 2, minus 4, and which is parallel to the vector 3i cap plus 2j cap minus 8k cap. So we have just learned that what is the vector equation. Vector equation is r vector is equal to a plus lambda into b. That is the vector equation. So in this case the vector a is nothing but 5i cap plus 2j cap minus 4k cap. Why? Because that line is passing through this fixed point 5, 2, minus 4, and it is parallel to the vector 3i cap plus 2j cap minus 8k cap. That means that is the vector b. Done. We got the vector a, we got the vector b, so this one we have applied here, and we get the equation r equal to 5i cap plus 2j cap minus 4k cap plus lambda into 3i cap plus 2j cap minus 8k cap, and this is the required vector equation of the line. Okay. Now let us concentrate to find the Cartesian equation of that line. Now there are two ways we can do. As we know the vector equation, we have expressed this in the in a component form. So r vector means what? Xi cap plus yj cap plus zk cap, because r vector means it is if x y z be any point on that given straight line, then its position vector is xi cap plus yj cap plus zk cap, and that is equal to the vector a plus lambda into vector b. So that means we have written this, and we know this coefficient of I cap in the right hand side should be equal to the coefficient of I cap in the left hand side. Similarly, coefficient of j cap in the right hand side, that is 2 plus 2 lambda, must be equal to the coefficient of j cap in the left hand side, that is y, and minus 4 minus 8 lambda, which is the coefficient of k cap in the right hand side, should be equal to z, which is the coefficient of k cap in the left hand side. So if we write this thing and eliminate lambda, we get this equation. Okay. So 5 plus 3 lambda, if I can write 5 plus 3 lambda is equal to x. So that means lambda equal to x minus 5 by 3. That means lambda equal to x minus 5 divided by 3. Similarly, 2 plus 2 lambda, 2 plus 2 lambda is equal to y. That means lambda equal to y minus 2 divided by 2, and minus 4 minus 8 lambda is equal to z. That means lambda equal to z plus 4 divided by minus 8. So all these three different values of lambda we have written here, and we get the Cartesian equation. But there is a much simpler way we can find the Cartesian equation, and let me show you how we can find the Cartesian equation in much simpler manner. So let me use in a different color, blue color. So what is the question? Find the vector equation and Cartesian. Vector equation we already found it out, so we are considering on the Cartesian equation of the line through the point 5, 2, minus 4. The moment I read that portion of the line, what comes to my mind is that it's Cartesian equation will be something like this: x minus x coordinate, that is x minus 5 by something, that is something means that is the direction ratios of that given of the line which you are going to find. So x minus 5 by something, y minus 2 by something, that is equal to z minus 4, that is z plus 4 by something. Now what is this something? Is nothing but the direction ratio of the line. Now in the next statement of the given question is that which is parallel, that means that line is parallel to the vector 3i cap plus 2j cap minus 8k cap. That means what? The direction ratios of the lines are 3, 2, minus 8. Pass we have written here, and that is the same equation as you see here. So we are able to understood that how this particular question has been solved. Okay. Now let us solve another question. Okay. So let me bring this one. Okay. Question number. Okay, it's done. Now let's go to the next topic actually, and the next topic what we are going to discuss is that how to find the equation of a line passing through two given points. Okay, so let's see how we can find it out. So dear students, as we discussed at the beginning of the session, that a straight line can be determined uniquely if it is passing through a fixed point and having a given direction, which we have just now completed. Okay. Now the second one is that we can also find the equation of a line uniquely if it is passing through two fixed points, and in this case these two fixed points are A and B. This is the point A whose position vector is the vector A and whose Cartesian coordinate is x1, y1, z1. Similarly, for the point B, its position vector is the vector B and its Cartesian coordinate is x2, y2, z2. Or in simple term, the moment I say the position vector of the point A is a vector, that means OA is equal to A. That means OA is equal to the vector A, where O is the origin. Similarly, the vector OB is actually vector B. Correct? And now as we are going to find the equation of that straight line, we need to consider an arbitrary point which lie on that straight line, and let's consider the point P. Now as it is an arbitrary point, its position vector we consider as R and its coordinates in the Cartesian coordinate system take x, y, z. That is the convention. Now what is the vector AP? Let's look into the same thing, whatever we discussed earlier. In the triangle OAP, if we look into the triangle OAP, and what we can write is that the vector AP, the vector AP is nothing but the vector AO, correct, plus vector OP. Clear? Now what is vector AO? vector AO is nothing but minus of vector OA and plus vector OP. So that means we get AP equal to OP minus OA. Now what is OP? OP is the vector R, and what is OA? OA is A. So that means vector AP is nothing but R vector minus A vector, which is written here. And what is vector AB? Vector AB in the similar logic is nothing but B minus A. Means to find that how we get the vector AB, vector AB. So we can consider the triangle OAB, and what we can write from here is that the vector AB is nothing but that vector AO, okay, plus vector OB, correct. So now that means vector AO means minus vector OA plus vector OB. Now what is the vector minus OA? That is minus A, and OB is nothing but vector B. So that means that is vector B minus vector A. So that is what is written here. AB, vector AB is equal to B vector minus A vector. Now let us concentrate on these two vectors AP and AB. What is the vector AP? This is the vector AP, correct? And what is the vector AB? This is the vector AB. Now both the vectors are collinear vectors. So then the vector AP should be a scalar multiple of the vector AB. That's what we know. If two vectors are collinear, then one vector is a scalar multiple of the other vector. So in this case, two vectors AP and AB are collinear. So the vector AP, which is R vector minus A vector, is a scalar multiple. That is, scalar multiple means we multiplied by lambda into the vector AB, that is B minus A, and that is the given vector equation of a straight line passing through two fixed points whose position vectors are A and B respectively, correct. So this is the way we can find the vector equation of a straight line. I repeat once more, vector equation of a straight line passing through two fixed points A and B whose position vectors are vector A and vector B is represented as, the equation is represented as R vector minus A vector is equal to lambda into B vector minus A vector, where lambda is a real number. You vary lambda, you get different points on that straight line. Okay, in the same logic, means if I elaborate little bit whatever I explained earlier when we derived the earlier equation, from here what we get, R vector is equal to A vector plus lambda into B vector minus A vector. Now let us concentrate on the right hand side, dear students. We see both A and B are fixed. What we can vary? We can only vary lambda because it is a real number. So we vary different values of lambda. We get different points on that straight line, and those points, position vector will be R. So either you can write the vector equation in the form of R minus A equal to lambda into B minus A, or you can write R equal to A plus lambda into B minus A. Both are fine. Okay, in fact both are same. Okay, so this is the Cartesian equation, this is the vector equation. Now let us concentrate to find the Cartesian equation of the same line. Very simple, and you will understand in a very effectively. Let me show you. So dear students, we know the vector equation of that straight line as R equal to A plus lambda into B. where lambda is a real number. Now A and B are fixed, fixed points. So coordinates of the point A, which is represented by the vector A, is x1 comma y1 comma z1. Let me go back to the previous diagram. The point A, whose position vector is A, is its Cartesian coordinates are x1 comma y1 comma z1. So then what it will be the vector A represented in the component form? The vector A will be x1 I cap plus y1 j cap plus z1 k cap, which is actually written here. You see, exactly it is written here like this. This one. In the similar manner, the point B is having a position vector B vector, and its Cartesian coordinates are x2 comma y2 comma z2. So what we can write? The vector B is equal to x2 I cap plus y2 j cap plus z2 k cap. Correct? Now R is an arbitrary point, so its component form is x1 I cap plus y1 j cap plus z1 x I cap plus y j cap plus z k cap. All these three values, that is the vector R, vector A and vector B, if we represent it here, and we will get something like this. After that what we will do? We will equate the coefficient of I cap, j cap and k cap in both the sides. And then what we will get, dear students? We will get something like this: x equal to x1 plus lambda into x2 minus x1. Okay, because x is the coefficient of I cap in the left hand side. So then what is the coefficient of, let me write little bit properly so that I cap should not be abolished. And what is the coefficient of I cap in the right hand side? It is x1 plus lambda into x2 minus x1. Correct, na? That's what we have written here, that x equal to x1 plus lambda into x2 minus x1. In the similar manner, we will get y equal to y1 plus lambda into y2 minus y1, and z equal to z1 plus lambda into z2 minus z1. Similar manner, whatever we have done earlier, that is eliminate lambda. If we eliminate lambda, we will get x minus x1 by x2 minus x1 is equal to y minus y1 by y2 minus y1 is equal to z minus z1 by z2 minus z1, which is the Cartesian form of the equation. So I repeat, dear students, once more. If a straight line passing through two fixed points whose position vectors are A and B, then what is the equation of that straight line? Vector equation: r vector is equal to A vector plus lambda into B vector minus A vector. That is the vector equation. Now to find the Cartesian equation, the position vector of the point A is A vector. So that particular point is having the Cartesian coordinates x1 comma y1 comma z1. You see the correlation. The point A having the position vector A, arrow here, the vector representation, vector A, and its corresponding for that same points Cartesian coordinate is x1 comma y1 comma z1, and for the point another fixed point whose position vector is B vector and its Cartesian coordinate, that particular point's Cartesian coordinates is x2 comma y2 comma z2. Then we get the Cartesian equation of that straight line as x minus x1 divided by x2 minus x1 is equal to y minus y1 by y2 minus y1 is equal to z minus z1 by z2 minus z1. I hope it is clear. Now dear students, important point. What is x2 minus x1, y2 minus y1, z2 minus z1? It is nothing but the direction ratio of a straight line passing through two fixed points whose coordinates are x1, y1, z1 and x2, y2, z2. Same thing we have done it here, because if you remember, when we derive the Cartesian equation of a straight line through a fixed passing through a fixed point and parallel to a vector b, and that vector b is Cartesian, that direction ratios were a, b, c. So here in this case it is x2 minus x1, y2 minus y1, z2 minus z1. I hope it is clear. Now let's concentrate on solving a question. So the first question I am going to write it here, because not only theoretical understanding will help, we need to solve some relevant question. What is the question? Very relevant, very important for your board examination. The question is that find the vector equation for the line passing through the point -1, 0, 2 and 3, 4, 6. The moment this statement is written, this statement we read that passing through the points, that means what? If we consider this point as the point A, so its vector representation is position vector should be -1 into I cap plus 0 into j cap plus 2 into k cap, which is nothing but this one, you see, minus I cap plus 2 k cap, because j component is 0, because 0 into j cap. And the other point is, dear students, is 3, 4, 6. If we consider this point as point B and its position vector is B vector, then obviously B vector will be what? 3i cap plus 4j cap plus 6k cap. So we found A vector and B vector. The moment we found A vector and B vector, we can find the vector B minus vector A. Okay. Then we apply the standard formula, that vector equation is equal to R vector is equal to A vector plus lambda into B vector minus A vector. So this is R here, A vector is here, that I minus I cap plus 2k cap, lambda is a real number, B minus vector is here. I hope it is clear. Now dear students, let's concentrate on another question, and here it is. The question what has been mentioned here, let me first place it in the screen. The question here is that the Cartesian equation of a line is given, which is x plus 3 by 2 is equal to y minus 5 by 4 is equal to z plus 6 by 2. We need to find its vector equation of that line. Very relevant question. Now we know that if a straight line is passing through a fixed point x1, y1, z1 and having direction ratios a, b, c, then its Cartesian equation is this, as you see it here. X minus x1 by a is equal to y minus y1 by b is equal to z minus z1 by c. In our case, x1 is equal to minus 3, y1 equal to 5 and z1 equal to minus 6, means if we equate these two straight lines, okay, this straight line and this straight line, if we equate, we get these are the values of x1, y1, z1 and a, b and c. After that it is very easy. because we know the vector equation is equal to r plus r vector equal to a plus lambda b. What is a? Minus 3 I cap plus 5 j cap minus 6 k cap, because this is a fixed point, correct, plus lambda into b. What is b? B is nothing but b vector. B means b vector is equal to 2 I cap plus 4 j cap plus 2 k cap. Done. So let me write it down here. Sorry. Okay, so whatever I said, actually it is written here. So the required the required line passes to the point minus 3 comma 5 comma minus 6. So that means its position vector, whatever the Cartesian coordinate you see, its position vector will be this minus 3 I cap plus 5 j cap minus 6 k cap, and it is parallel to the vector 2 I cap plus 4 j cap plus 2 k cap. That means the vector b will be this 2 I cap plus 4 j cap plus 2 k cap, and same thing, the vector r is equal to a plus lambda into b vector, where lambda belongs to capital R, the set of all real numbers. Now dear students, let me show you a easy technique also. So as the Cartesian equation is given, so we need to find the vector equation. So what we will write? R vector is equal to a vector. A vector will be what? Minus 3 I cap. So you will make a negation of this. You will make a negation of this. Minus of minus 5 become plus 5. Okay, and negation of this, that is minus 6 k cap plus lambda into whatever you see in the denominator 2 4 2. So it will be 2 I cap for this one, 2 I cap plus 4 j cap plus 2 k cap plus 2 k cap. Done. So this is the equation, exactly whatever we have done, derived a minute back, the same thing here. I hope it is clear, dear students. Now let's proceed to the next point, and next point is that the angle between two lines. Okay, so how to find the angle between two lines, and we are going to understand now. So dear students, let us consider there are two straight lines, L1 and L2, and both the lines are passing through the origin. Okay, so as you see here, L1 is a line and L2 is a line. Sorry, L1 is a line here. Let me say from the beginning. L1 is a line here and L2 is a line here. Both are passing through the origin, and both these lines, the lines L1's direction ratios are A1 comma B1 comma C1. Okay, so this is the direction ratio of the line L1, and that of line L2 is A2 comma B2 comma C2. Correct. Now let us consider 2 points, point P on the line L1 and point Q on the line L2. So we get the two directed lines OP and OQ, and let us consider that theta be the acute angle between these two lines. Okay, theta be the acute angle between OP and OQ. So what I am saying, dear students, let theta be the acute angle between OP and OQ. Now if you recall whatever we discussed earlier means not in today's class, earlier classes, that if we have two directed lines OP and OQ having components A1, B1, C1 and A2, B2, C2. So what will be the value of cos theta? The value of cos theta means where theta is the acute angle between these two vectors is A1 A2 plus B1 B2 plus C1 C2 divided by square root of A1 square plus B1 square plus C1 square into square root of A2 square plus B2 square plus C2 square. That we have learned from the vector algebra. I repeat once more. If the vector OP is having the components A1, B1, C1 means a vector component, means we can say in the other way the vector OP can be represented as A1 I cap plus B1 J cap plus C1 K cap, and vector OQ can be represented as A2 I cap plus B2 J cap plus C2 K cap, and if theta be the acute angle between them, then this expression represents the cosine of that angle. And you see we took the mod value. Why we took the mod value? Because we considered theta as the acute angle, and cosine of acute angle is always positive, so we considered the mod value. I hope it is clear, dear students. Now, and you need to remember that one. Okay. Now if we need to find the same angle in the not in the form of cosine but in the form of sine, it is just we need to make some algebraic simplification, because we know sine theta is equal to square root of 1 minus cos square theta. So here we are not considering the negative value of sine theta because of the same reason that theta is an acute angle. So here cos square theta value we have applied here. After that we perform the algebraic simplification and we get this one. Now it may possible that line L1 and L2 do not pass through the origin. In that case what we will do? In that case we will draw two lines L1 dash and L2 dash which are parallel to the line L1 and L2, but they are passing through the origin. What does it mean? So if I can explain this note here, suppose these are the coordinate axis. Okay, so this is origin. Suppose this is x-axis, this is y-axis, and this is z-axis. Suppose our lines, let me draw it in the green color. Suppose this is the line L1. Okay, so this is the line L1 and this is the line. Okay, let me draw it in different one. Suppose this is the line L2. Now if you see, both the lines L1 and L2 are not passing through the origin. So what has been mentioned in this note is that if this is the case, then what we will do? We will draw a line L1 dash parallel to L1. That means the L1 dash will be something like this. Okay, let me just a minute, let me draw properly. So it will be the line L1 dash actually. L1 dash is parallel to L1 but it is passing to the origin. And similarly we can draw L2 dash which is parallel to, just a minute, which is parallel to L2, like this. Okay, that is L2 dash. Now we can find the angle between L1 dash and L2 dash. That will be the same as angle between L1 and L2. Okay, dear students, so now let's proceed to the next point. Okay, now instead of the direction ratios, if we consider the direction cosines of the lines L1 and L2 as L1 M1 N1 and L2 M2 N2 respectively, then what will happen, dear students? The angle between those two lines will be, cosine of that angle will be mod of L1 L2 plus M1 M2 plus N1 N2. How come we derive this one? Ideally, the cos theta will be what? The cos theta will be mod of L1 L2 plus M1 M2 plus N1 N2 divided by square root of L1 square plus M1 square plus N1 square into square root of L2 square plus M2 square plus N2 square. Why so? Because we are writing this because we have learned this one, correct? In this case, A1 B1 C1 A2 B2 C2 are direction ratios, but in this case it is L1 M1 N1 and L2 M2 N2 are direction cosines. But we know a direction cosine is also a direction ratio. Converse may not be true, but a direction cosine is always a direction ratio, so we can write this one. But here the point is that as L1 M1 N1 are direction cosines, so sum of their squares is equal to 1. That's what we have written it here. This is equal to 1 and that is equal to L2 square plus M2 square plus N2 square. So as denominator become 1, we get the value of cos theta as mod of L1 L2 plus M1 M2 plus N1 N2. And in the similar manner we can get the sin theta also. However, sin theta is not widely used, so you can remember the cos theta. If you remember sin theta, it is good. Now, what will happen if the lines are perpendicular to each other? Perpendicular to each other means what? Cos theta, theta will be 90 degree and cos of 90 degree is 0. Cos of 90 degree is equal to 0. Let me again go back. So, if this component, if this expression has to be equal to 0, that means what? That means the numerator has to be equal to 0. That means A1 A2 plus B1 B2 plus C1 C2 has to be equal to 0, and this is what is written here. If two straight lines having direction ratios A1 B1 C1 and A2 B2 C2 are perpendicular to each other, then this relationship must hold true, that is A1 B1 A1 A2 plus B1 B2 plus C1 C2 has to be equal to 0. And if they are parallel to each other, that means what? Their direction ratios are in proportional. We know that we have discussed earlier, right? If two straight lines direction ratios are proportional, that means those two straight lines are parallel, and vice versa. If two straight lines are parallel to each other, then their direction ratios must be proportional. That means what? A1 by A2 is equal to B1 by B2 is equal to C1 by C2. Okay, dear students, so I hope you got a very clear idea. Now, let us find the angle between the two lines when their equations are given. Okay, it is actually derived from the previous one only, but this is very important to answer specific questions. Generally what happens, dear students, is that suppose equation of two straight lines are given and you have been asked to find the angle between those two straight lines. Now, as the equation of those two straight lines are given, then equation can be either given in vector form or in Cartesian form. So, let us see that how to find the angle between those two lines when the equation of those two lines are given either in vector form or in Cartesian form. Suppose those two lines, that is L1 and L2, suppose this is the vector equation of the line L1, that is R vector is equal to A1 vector plus lambda into B1 vector. And let us consider this vector, this equation, that is R vector is equal to A2 vector plus mu into B2 vector is the vector equation of the line L2. So, then what will be the cos theta? Cos theta will be mod of, where theta is the acute angle between these two lines. Okay, it is mentioned acute. Cos theta equal to mod of b1 vector dot b2 vector divided by mod of b1 vector into mod of b2 vector. And you know, dear students, this is actually coming from the dot product, if you recall. So when we are finding the angle between these two lines, that is nothing but finding the angle between the vectors b1 vector and b2 vector. Why? Because this line L1, whose vector representation as is r vector equal to a1 vector plus lambda b1 vector, that means this straight line is parallel to the vector b1, and similarly the L2 straight line is parallel to the vector b2. So that means what? Finding the angle between L1 and L2 is nothing but finding the angle between the vectors b1 and b2. And if you recall that the dot product between two vectors b1 vector dot b2 vector is equal to what? You know, mod of b1 into mod of b2 vector algebra, if you recall, into cos theta. So from there only we find this value of cos theta. Now let us concentrate if both the equations are given in Cartesian form. That is, first straight line is that L1, whose vector representation is r vector equal to a1 vector plus lambda b1 vector. Its Cartesian representation is x minus x1 by a1 equal to y minus y1 by b1 is equal to z minus z1 by c1. Now the another straight line L2, whose vector representation is r vector is equal to a2 vector plus mu into v2 vector, and its Cartesian representation is x minus x2 by a2 is equal to y minus y2 by b2 is equal to z minus z2 by c2. That means what? These two vectors are having direction ratios a1 b1 c1 and a2 b2 c2. Now finding the angle between these two straight lines is nothing but finding the angle between two lines whose direction ratios are a1 b1 c1 and a2 b2 c2, and for that we have just learned few minutes back. This is the formula, that cos theta equal to mod of a1 a2 plus b1 b2 plus c1 c2 divided by square root of a1 square plus b1 square plus c1 square into square root of a2 square plus b2 square plus c2 square. That is the angle. Okay, so this is the value of the cosine in the when the equation is given in the Cartesian form, and this is the value of the cosine. Let me block properly cosine when the equations are given in the vector form. Okay, dear students, so now let's solve couple of questions quickly. Okay, the first question. So I know this session is little lengthy, but I will not take more than 5 minutes. Okay, but you need to, you know, this recorded lecture will be available in YouTube by tomorrow, so you need to, you know, look at it multiple times to understand, because a lot of things has been discussed. So here the question is, find the angle between the pair of lines given by r vector equal to the first one you see and second one. Quite simple, we just need to apply the formula, that here we need to, as if we need to find the angle between two vectors, this vector and this vector. That's it. So let's find it out. So let me place the solution from my note, and let me place it here. Okay, so as I was telling, that here the vector b1 is this one, I cap plus 2 j cap plus 2 k cap, and the vector b2 is 3 I cap plus 2 j cap plus 6 k cap. After that, we have just learned few minutes back, when both the equations are given in the vector form, what is the formula to find the angle cos theta equal to mod of b1 vector dot b2 vector divided by mod of b1 vector into mod of b2 vector. Exactly the same thing we are doing here. Okay, same thing. And you know how to find the b1 dot b2, that is the product of their I component plus product of their j component plus product of their k component, which is 3 plus 4 plus 12, and divided by mod of b1, which is 3, into mod of b2, which is 7, and we get cos theta equal to 19 by 21. That means theta equal to cos inverse of 19 by 21. Got it? Last question for today, and this question I am going to place it here. So the earlier one for vector equation, and here is for Cartesian equation. So when we discuss about theory, the relevant problem solving is also important. So that makes our learning complete. Find the angle between the pair of lines. Okay, so two lines has been given. The moment you read this one, as if you need to find the angle between two lines whose direction ratios are 3, 5, 4 and 1, 1, 2. Exactly 3, 5, 4 and 1, 1, 2. Let's assume that theta be the acute angle. So it has to be written as acute. Theta be the acute. If something is not mentioned, that means it is acute. So cos theta equal to mod of the formula whatever we just discussed few minutes back, that a1 a2 mod of a1 a2 plus b1 b2 plus c1 c2 divided by square root of a1 square plus b1 square plus c1 square into square root of a2 square plus b2 square plus c2 square. Exactly the same thing we have applied here. Okay. a1 a2, that means 3 into 1 plus b1 b2, that is 5 into 1 plus c1 c2, that is 4 into 2 divided by square root of a1 square plus b1 square plus c1 square, that is square root of 3 square plus 5 square plus 4 square plus square root of a2 square plus b2 square plus c2 square, that is 1 square plus 1 square plus 2 square. We get 16 divided by square root of 15 to square root of 6, and after that, after rationalization of the denominator, we get 8 into root 3 by 15. As cos theta equal to 8 into root 3 by 15, so theta is equal to cos inverse of 8 into root 3 by 15. So with this note, let me conclude the class here, dear students. In the next class, we will discuss the distance between two lines. In case you have any question, please do let me know. In case you do not have any question, we can conclude the class here. Thank you very much.
Thank you, sir.
Thank you, sir.